Why does the act of scrolling feel impossible to stop? Many perceive this as a personal failure of willpower. However, by 2026, we understand that this is not a simple lack of willpower. It is a precise biological response to algorithmic stimuli. The infinite feed is engineered to exploit ancient neural pathways, turning passive screen time into a compulsive cycle. This video series explores the neuroscience hidden behind your screen time. Contrary to popular belief, dopamine is not a simple pleasure chemical. Chemically, it functions as a primary driver of the brain's motivational system. Dopamine signals to your brain that an important stimulus is approaching. It provides the biological impetus that compels you to seek out, focus on, and engage with your environment. Dopamine is not simply a chemical of pleasure, but of anticipation and pursuit. The brain operates using a mechanism known as the dopamine prediction error. This mechanism calculates the difference between the reward you expect and the reward you actually receive. If an outcome is better than predicted, neurons fire rapidly. If it is predictable, the signal flattens. Modern interfaces turn this into a variable reward schedule. Every scroll is a gamble. Because the brain cannot predict if the next post will be mundane or highly rewarding, the uncertainty itself triggers a massive dopamine release. Biological models show peak activity at a 50% reward probability. By keeping content unpredictable, platforms ensure the prediction error remains active, fueling the cycle of constant engagement. The ventral tegmental area, or VTA, serves as the fundamental engine of our brain's motivational system. When you scroll through digital content, the VTA is triggered. It activates a critical neural pathway that projects directly to the nucleus accumbens. This circuit is highly conserved and mirrors the pathways involved in substance addiction. It reinforces a persistent habit of wanting more content, even when actual satisfaction remains elusive. Social media platforms utilize the variable reward schedule, a principle derived from operant conditioning. Much like a slot machine, the delivery of a reward, such as an interesting post or viral video, is unpredictable. The internal mechanics of a slot machine illustrate the structural design of digital feeds. Just as mechanical switches trigger a payout, each interaction in a feed is designed to capitalize on the user's anticipation of a reward. Psychological data shows that variable ratio schedules create high, steady rates of responding. Because the brain cannot predict the win, it remains locked in a loop of continuous engagement. This concept was pioneered by B.F. Skinner. By observing animal behavior, researchers found that intermittent reinforcement is significantly more resistant to habit extinction than fixed, predictable rewards. Consequently, users repeat the interaction indefinitely. The variability of the reward is not a bug, it is the fundamental mechanism that drives modern digital consumption. Algorithms are precision engineered to locate your specific Goldilocks cognitive load. This is the optimal state where content is familiar enough for effortless processing, yet novel enough to trigger an orientation response. If content is too simple, the brain dismisses it as redundant. If it is too complex, the cognitive cost of processing leads to immediate disengagement. The algorithm constantly calibrates to keep you within this narrow band. Digital content consumption operates on a strict temporal constraint. Research indicates that the brain requires engagement within approximately 2.8 seconds to maintain passive focus. If content fails to hook the user within this window, the prefrontal cortex, the brain's center for executive control, attempts to regain authority over the user's focus. However, modern algorithms are specifically engineered to bypass this cognitive gatekeeper. By flooding the brain with high-novelty, high-stimulus cues, they effectively mute the prefrontal cortex. Once this threshold is bypassed, the user is moved from active decision-making into a state of passive algorithmic consumption. This mechanism effectively diminishes our capacity for sustained task switching and reflection, illustrating the significant cognitive cost of rapid-fire digital environments. By 2026, the digital experience shifted from static content to dynamic AI-synthesized feeds. AI-driven feed aggregation services now process real-time personalization logic at an architectural level, ranking and curating content before it even reaches the edge cache. The current feedback loop is instant. Biometric data and dwell time are continuously transmitted back to the generative model, which adjusts content in real time. This creates a reciprocal communication flow where the machine and user are locked in a closed-loop engagement cycle designed to maximize time spent. Modern digital interfaces increasingly utilize biometric integration. By monitoring physiological markers such as heart rate variability and pupil dilation, algorithms gain direct insight into your autonomic nervous system state. This constant data feed creates a closed-loop system. When the algorithm detects a state of physiological boredom or lowered engagement, it triggers a high-stimulus content spike. This is specifically designed to re-engage your attention and maximize your dwell time. Effectively, the technology treats your autonomic nervous system as a variable to be managed. This dynamic adaptation ensures that the digital feed remains optimized for your specific neurobiological response. High engagement video content induces a state known as neural coupling. Research using fMRI technology shows that a viewer's brain activity patterns begin to synchronize with the emotional state expressed by the creator. This synchrony occurs across multiple modalities, including behavioral, neural, and physiological channels. By aligning these systems, the brain treats the digital experience as a genuine interpersonal interaction. Because the viewer's neural activity aligns with the creator, the message is perceived as highly intimate. This phenomenon effectively bypasses defensive cognitive barriers, making the content remarkably difficult to disengage from. Digital anhedonia describes a state of diminished capacity for pleasure resulting from chronic digital overstimulation. Constant exposure to high-frequency algorithmic content forces the brain to compensate for persistent overstimulation. To maintain homeostasis, the brain downregulates dopamine receptor sensitivity. As receptors become less sensitive, the baseline required to feel reward shifts drastically higher. Consequently, real-world activities like reading, socializing, or walking appear unrewarding because they cannot match the intensity of the digital feed. This creates a feedback loop that compels further digital consumption to reach a feeling of normalcy. A landmark 2025 longitudinal study tracked 10,000 adolescents to analyze the cognitive impact of rapid-fire short-form digital content. A longitudinal approach allows researchers to observe the same individuals repeatedly over time, capturing measurable changes in neural development. The data revealed that adolescents consuming over 3 hours of rapid-fire content daily exhibited a 15% reduction in sustained task switching efficiency. The prefrontal cortex acts as the brain's executive controller. It is the seat of long-term goal setting, impulse control, and rational decision-making. It manages complex tasks by evaluating future consequences. However, during rapid-fire digital consumption, this sophisticated system faces a constant uphill battle against more primitive drives. In a scrolling loop, the brain's reward centers aggressively signal the need for immediate dopamine release. This process can effectively hijack the prefrontal cortex, dampening its ability to exert top-down control. This creates a state where you remain engaged with content even when you are cognitively aware that you should stop. The battle is not one of personal failure, but a physiological struggle between executive intent and neural reward drives. Passive consumption is energy efficient for the brain in the short term, as it requires minimal active processing. However, this state carries significant hidden costs for your long-term cognitive health. Passive media creates excessive extraneous load on the brain. While intrinsic load is necessary for learning, the constant stream of irrelevant stimuli from digital feeds exhausts the cognitive resources required for deep, meaningful processing. Over time, this habit fragments your attention span. What begins as a brief pause becomes a habit of constant mental context switching, making deep, sustained work increasingly difficult for your future self. Ultimately, passive consumption acts as a form of cognitive debt. By choosing constant distraction today, you systematically reduce your brain's capacity for deep, focused work tomorrow. The relentless speed of modern interfaces exploits human neurobiology to maximize consumption. However, emerging research suggests that speed is often the enemy of genuine user satisfaction. Enter the concept of intentional friction or slow UI. By introducing deliberate micropauses or confirmation steps, designers can break the impulsive dopamine-driven scroll cycle. In pilot studies, implementing these pauses resulted in a 22% decrease in dwell time. Surprisingly, user well-being scores surged by 35%. These findings confirm a critical shift in UX philosophy. Speed is not a proxy for quality. Slow UI prioritizes user agency, offering a path out of the automated cycle of passive distraction. A growing trend of analog resistance is emerging in digital landscapes. Users are increasingly adopting focus-first interfaces that serve as structural buffers against rapid consumption. Focus-first interfaces utilize intentional friction. By introducing micropauses or slowing scroll velocity, these designs intentionally disrupt the automated dopamine loop. These design friction points allow the prefrontal cortex, responsible for executive decision-making, to re-engage. This break in the feed enables users to transition from passive consumption to conscious interaction. Ultimately, analog resistance is about reclaiming cognitive agency. By integrating ethical friction into our digital tools, we can effectively break the loop of distraction and restore a sustainable state of focus. Algorithmic transparency laws represent a shift in how society addresses digital health. Regulatory bodies worldwide are increasingly classifying addictive interface design as a public health concern, not merely a commercial strategy. Lawmakers are proposing disclosure requirements for reward frequency algorithms. This is directly analogous to nutrition labels on food, which provide transparency regarding the ingredients and health impacts of what we consume. By mandating this level of transparency, policies aim to empower users to recognize when they are being targeted by design elements that prioritize engagement over objective well-being. The open-loop principle is a powerful tool for creators. It functions by presenting valuable information while intentionally leaving a curiosity gap. This necessitates active participation from the viewer, moving them away from passive dopamine-driven scrolling. By adding intentional friction or questions, you require the prefrontal cortex to engage. Instead of a passive, endless loop, you create a structure that rewards active learning and cognitive mastery. Use the curiosity gap to build utility. When your content demands an answer, the user is no longer just watching, they are solving. To combat the dopamine-driven cycle of passive consumption, we can introduce ethical friction into our learning process. By introducing intentional pauses or critical questions during content, we break the autopilot of continuous scrolling. This simple act of introducing friction shifts your brain from reactive consumption to high-level critical thinking. Choose to insert these friction points. It turns passive input into a meaningful, sustainable dopamine of mastery. Scrolling is a sophisticated battle between ancient biological reward systems and modern algorithmic engineering. Algorithms identify patterns in your attention to deliver stimuli that trigger the brain's dopamine reward pathway. This creates an automated feedback loop that often replaces deep cognitive engagement with passive, high-frequency stimulus. Understanding this process is the fundamental first step toward regaining control over your digital attention. By recognizing the science, you shift from a passive subject of an algorithm to an active participant in your own cognitive environment. Our brain is evolutionarily wired to pursue novelty. Modern digital feeds exploit this ancient dopamine loop by providing an infinite stream of unpredictable rewards, keeping us in a state of passive consumption. By understanding this neuroscience, you can regain control. Choose mastery over distraction. Prioritize deep learning tasks, limit passive scrolling, and curate your environment to favor utility over the infinite empty scroll. The choice is yours. Protect your attention, nurture your focus, and choose meaningful experiences.